Hi everyone! Today we're going to continue Chapter 1. So last time we talked about the scientific method, or how scientists think and conduct experiments. Today we're going to just go over some key math skills for chemistry, and some of this might be review, so it's okay if you want to kind of fast forward through certain parts. But I want to make sure that everybody is on the same page. So if you haven't seen some of this stuff in a while, this is a good review. All right, so today we're going to review some math concepts. So we'll go over place values, positive and negative numbers, percentages, solving equations, and interpreting graphs. So first, let's talk about place values. So for any number, we can identify the place value for each of the digits in that number. So a couple of examples are below. In the first example, a premature baby has a mass of 2,518 grams. Now, each of those digits can be assigned a place value. So the 2 is in the thousands place. The 5 is in the hundreds place, the 1 is in the tens place, and the 8 is in the ones place. So we have the thousands place, the hundreds place, the tens place, and the ones place. Now what if we have a smaller number with a decimal? So on the right we have the example where a silver coin has a mass of 6.407 grams. So the 6 is in the ones place, so that's kind of similar to the 8 in our previous value. But now we have a decimal point. So once we go past the decimal point, now we say that the 4 is in the tenths place. So notice that we're talking about a fraction here. So you could also consider that that's 4 out of 10. The 0 is in the hundredths place, and the 7 is in the thousandths place. So, for instance, we said that the 4 is in the tenths place because we technically have a fraction of 4 over 10. The 0 would be out of 100, and the 7 would be out of 1,000. All right. So now let's do a practice problem. What is the place value for the underlined digit in 35.679? And the underlined digit is the 7. So feel free to pause the video if you want to think about it for a little bit. All right, so which place is, or what is the place value for that 7? So that would be in the hundredths place. All right, so let's kind of go over each of these digits. So the 3 is in which place? That's in the tens place. And then the 5 is in which place? The ones place. And then once we move past the decimal, the 6 is in the tenths place. The 7 is in, we said, the hundredths place. And then the 9 will be in the thousandths place. So, for instance, what we're really doing here for that number, we have the 3 in the tens place, so we've got 30. And then the 5 is in the ones place. The 6 is in the tenths place, so we could write that we're actually adding 6/10 to that number. And then we've got 7 out of 100, so that's the hundredths place. And finally, we have 9 out of 1,000, so that's in the thousandths place. So if we add all of these together, we get 35.679. So hopefully these place values make sense. The reason why this is important is later on we're going to learn about significant figures. So we're going to discuss which numbers in a measurement are significant and which of the digits in a number or a measurement are insignificant. So we're going to have to be able to identify, for instance, the tenths place, the hundredths place, or the thousandths place. So this does have a purpose. All right, and here's the solution slide if you want to review that later. So now let's review positive and negative numbers and calculations. Now, you might remember that a positive number is any number that is greater than 0 and has a positive sign. So often the positive sign is just understood, so we don't actually write it in front of the value. And then a negative number is any number that is less than 0, and of course we write that with a negative sign. And of course we do need to include that negative sign, otherwise we'll assume the number is positive. Now, when we're using positive and negative numbers in calculations, so for instance, in multiplication and division, remember that two positive numbers or two negative numbers that are multiplied or divided will give a positive answer. So we have a few examples listed here. We have 2 times 3, so we have two positive numbers, and that's going to equal positive 6. And then in the second example, we have two negative numbers, negative 2 times negative 3, and that will also give us a positive number, so positive 6. And then if we divide 6 by 3, and both of those values are positive, we get a positive answer, which is positive 2. And then if, let's say we have negative 6 divided by negative 3, that will also give us a positive value of 2. All right, now what if we have a mix? What if we have a positive number and a negative number that are either multiplied or divided? The answer will be negative. So, for instance, if we have positive 2 multiplied by negative 3, that will give us negative 6. And same if we switch the negative sign. So if we have negative 2 times positive 3, we also get negative 6. And then in the third example, we have positive 6 divided by negative 3, and that will give us negative 2, because there is only one negative sign in our calculation. And same if we flip the negative sign to the other number, so negative 6 divided by positive 3 will also give negative 2. All right. Now, what about addition and addition of positive and negative numbers? So when two positive numbers are added, the sign of the answer is positive. But when two negative numbers are added, the sign of the answer is negative. So for instance, if we have two positive values, positive 3 and positive 4 that are added together, that gives us positive 7. Now, what if both of those values are negative? So if we have negative 3 plus negative 4, that gives us a negative value, negative 7. Now, if we have a mix, so let's say we have a positive number and a negative number that are added together, the smaller number is subtracted from the larger number, and the result has the same sign as the larger number. So as an example, we have 12, so positive 12, plus negative 15, and the answer is negative 3. So the smaller number, 12, we can say is subtracted from the larger number, 15. So we're just thinking about magnitude there. So the difference between 12 and 15 is 3. And then the answer will have the same sign as the larger number, which in this case is 15. And that larger number is negative, so our answer will also be negative. Now, if you have a different way of thinking about this, so if you were taught how to solve these problems in a different way, go for it as long as you get the same answer or the right answer that I do. I know that everyone has different ways of doing math. I was taught very differently from my younger sister, for instance. So just as long as you get the same answer, that's all that matters. All right, so now subtraction of positive and negative numbers. So when two numbers are subtracted, we're going to change the sign of the number that will be subtracted, and then we just follow the rules for addition. So for instance, let's say we have positive 12 minus positive 5. We're really just subtracting 5 from 12. And then remember, the sign of the answer is the same as the larger number, which was positive. And then if we have 12 minus negative 5, two negatives will actually make a positive. So we're really just adding those numbers together. Now if we have negative 12 minus negative 5, remember we're going to combine those two negatives to make a positive. So we really have negative 12 plus 5. And then we would get negative 7 as a result. And at the very last example, we have negative 12 minus positive 5. So really that would be negative 12 minus 5. So we would get negative 17. So again, a lot of this might be review, but just make sure you're getting the same answers that I am here, whichever way you prefer to solve for these equations. All right, so in chemistry, we do use calculators quite a bit. So typically in class, I would prefer that everyone use a scientific calculator, which looks kind of like the one shown down below. So this is a more simple calculator, but it does have certain functions like a logarithm function and a natural log function. However, I know everyone's at home right now, so if you have access to, for instance, a graphing calculator, that's totally fine. And if you don't have a calculator, you can always use a computer or your phone, just as long as you have access to the logarithm function, because that will come up later this quarter. Now, if you have trouble using your calculator, you can always just let me know, and I can help you work through how to use it. Or you can go to or email the MARC, so the Math Resource Center. They will help you out as well. All right, so down below is a figure of just some useful buttons on your calculator that you can use. But again, if you have trouble with your calculator, just let me know. All right, and then this slide shows some examples of how to plug in different equations into your calculator. One thing I will say when using a calculator, use as many parentheses as possible. So, for instance, let's say you're doing a division problem like this one. But let's say it's a little more complex than that. What if we have 8 times 3 divided by 4 times 3? Well, we might be able to simplify that, but what I would do is enter this into the calculator as 8 times 3 divided by parentheses 4 times 3. And that's just to make sure the calculator knows what operations you're doing and in what order. Sometimes the calculator might assume that you are plugging in 8 times 3 divided by 4 times 3, for instance, where it's assuming that you're dividing 3 by 4 and then you're multiplying the whole thing by 3. So just keep that in mind. We don't want to do that. Use as many parentheses as you can. All right, so now calculating percentages. Percentages do come up in chemistry quite a bit. Later on this quarter, we're going to talk about concentrations, which are really just fractions or percentages. So to determine a percentage, we want to divide the parts by the total and multiply by 100. So for example, let's say you have 32 total books on your bookshelf, and 8 of those books are chemistry books. We can figure out the percentage of your books that are chemistry related by taking 8, dividing it by 32, and multiplying by 100. And so we'd end up with 25%. Additionally, another example, let's say we're told that we have a percentage of 5. So for instance, if the percentage of red balls is 5, it means there are 5 red balls in every 100 balls. So you can take a percentage and convert it into a fraction. So you can also work backwards. So let's say, for instance, in the previous example, we're just told that we have 25% chemistry books. We could then convert that into 25 out of 100. All right, and then the next review is solving equations. So equations can be rearranged to solve for an unknown variable. So for instance, let's say we have an equation 2x plus 8 equals 14. And we want to figure out what x is equal to. The first thing we'll want to do is try to isolate x. So we can subtract 8 from both sides. So we're really placing all like terms on one side. And what we end up with is 2x is equal to 6. And then we're going to isolate x even further. We're going to divide both sides by 2 to get rid of the 2 by the x. So when we do that, we find that x is equal to 3. And then, of course, you can always check your answer by plugging in that value of x into the original equation. So 2 times 3 plus 8 is equal to 6 plus 8, which is equal to 14. All right, so normally in class, we would work on a worksheet labeled Day 1 Math Activity. So if you want to work on that on your own, you can, and try to do it without a calculator. Now, normally in class, I'd ask you to work with others or ask me questions, but really the goal of this worksheet is to refresh your memory on different calculations involving decimals and fractions, as well as division and multiplication, etc. I'll also post the key to this activity so that you can check your work. And again, this is review, but I do highly encourage you to go through it on your own. Okay, so the last thing we're going to cover today is how to interpret graphs. So in chemistry, we often use graphs to display data and show different trends or relationships between variables. So again, a graph represents the relationship between two variables, and it contains two perpendicular axes. So we have a horizontal axis, which is our x-axis, and then a vertical axis, which is the y-axis. And then we usually have some sort of data to plot there. So on this slide, we have a graph, and on the x-axis is temperature in degrees Celsius, and on the y-axis is volume in liters. And it looks like the title is volume of a balloon versus temperature. So this tells us what we are measuring. We're measuring the volume of a balloon at different temperatures. All right, so this graph shows us that there's a linear relationship between volume and temperature. So once we have our data plotted, we can also use that data to figure out what the volume of the balloon is at various temperatures. So let's say we want to figure out what the volume of a balloon is at, I don't know, let's say, well, it looks like 50 degrees Celsius here. So we can go up to the line and then extrapolate over to the y-axis and see that the volume of the balloon at 50 degrees Celsius is, let's say, about 26.5 liters. And that's an estimation, but we can also plug it into an equation for the line. So maybe we would figure out what the best fit line is for that data. Okay, so in the previous graph, we saw that the volume of a gas in a balloon is plotted against its temperature, and the y-axis represented the volume of the gas in the balloon, and then the x-axis represented the temperature of the gas in the balloon. And then the title indicated that the volume of the balloon was measured at different temperatures, and the points on the graph represented the volume of gas in liters that was measured at a specific temperature. So we're going to have the opportunity to make some graphs in this class, and that will be for different labs. So once we start getting into the labs, we'll go through how to plot graphs in Excel, for instance. But I think we'll stop there today. So again, that was a bit of review. Next time, we're going to go over how to write numbers in what's called scientific notation. So I will see you in the next video.